So when we look at graphing the logarithmic function, it helps to know what shape the logarithmic function is going to take. Now, the logarithmic function, as we have been seeing so far, is actually very similar to the exponential function. So if I'm going to just draw a little sketch here, just to kind of remind us what the exponential function looks like. The exponential function will typically have an asymptote, and the basic function has an asymptote along the x-axis here. And the function is going to kind of curve up like this, right here. So the logarithmic function is actually the inverse of the exponential function. So what that means is that if we were to draw in a dotted line of symmetry right here, and if we were to take this piece of paper, if this was a piece of paper right here, and fold it diagonally like this over this line, we're actually going to get this kind of a shape. And this is what the logarithmic function would look like. Now, the rule of the function is written like this. So this is the basic rule of the function. However, this is not the simplified version. So we often tend to use the simplified version, which is written like this. So this is the typical function that we would use to graph. You can use this one to graph as well, and sometimes you will be encountering functions in this form. However, this is the one that we're going to be mostly using today and in the future. This is actually called the standard form of this function. Now it's important to know that our b cannot be equal to 0, because if it was equal to 0, it would be a completely different function. Our c has to be greater than 0, but it cannot be equal to 1, because again, that would make this a completely different function. So with that in mind, we need to figure out a couple of things before we start graphing. So the h value actually relates directly to the vertical asymptote. And the equation for the asymptote will be equal, the equation for the asymptote is x is equal to h. So you can determine the vertical asymptote for this guy here. For the basic function, the vertical asymptote is your y-axis, but sometimes this will be shifted over and you might have a vertical asymptote here or a vertical asymptote here. The next thing is that we need to take a look at this point right here. That is your x-intercept. Now the x-intercept has the points at 1 over b plus h and 0. So if you've been given your b and your h, you can figure out the coordinates of your x-intercept. And then once you have these things marked out on your page here, or on your graph, then you can do your table of values. To find a couple more points. And once you have all of this, then you can actually draw in your curve. So let's take a look at an example here. So Let's say that the rule that we've been given is f of x is equal to log base 5 of 2 times x plus 1. So my equation of the asymptote is at x is equal to h. My h, remember, we always take the opposite sign, so that's going to become -1. So I'm going to draw in my asymptote at x is equal to -1 right away. Now, my x-intercept is at 1 over b plus h. So my b is 2, so 1 over 2. My h is -1. When I add this together, I should get -0.5 and 0. So this crosses at this point right here. Last but not least, let's make a table of values. So I'm going to say x is equal to 2 for one, and then I'm going to say that x is equal to 4 for another. I'm only going to choose 2 more points because I already have my x-intercept here. So f of x is equal to log base 5 of, oops, it's supposed to be 2 times 2 plus 1. So I would get 2 plus 1 is 3. 2 times 3 is 6. Now here, I can't just calculate this. I have to change my base. So when I change my base, I would get log, and I'm going to go with log base 10, log of 6 over log of 5. When I calculate that, log of 6 divided by log of 5 will give me 1.1, yeah, 1.1 approximately. So at 2, it will be at 1.1, which is all just above, really, it's just above that line there. And then, of course, I would do the same thing for x is equal to 4. So I would do 4 plus 1 is 5, 2 times 5 is 10, and then I would do log of 10 divided by log of 5, which would give me 1.4. So at 2, it would be almost halfway, but not quite. So then I can draw in my curve. So that one, it starts to flatten up down here, and this curves sharply right around the x-intercept, and it is going to continue downwards, hugging really close to that intercept, or that asymptote, I should say. And this is how I would graph a logarithmic function. Thank you guys for listening, and I'll see you guys next time.